Lab 9 is the first lab in Unit 3 on the Sun and stars. This lab will focus on using sunspots to determine solar rotation rate. The Sun has what is referred to as differential rotation, meaning that different parts of the Sun rotate at different rates. We will be using the website spaceweather.com to look at sunspot activity today and at a time in the past. You can see in this image we're looking at all the sunspots that were visible on the Sun back on January 1st of 2001. Notice that several spots are visible and that each group has a 4-digit number along with it. If you click on this image of the Sun, you'll get a zoomed in image of the spots, but the 4-digit numbers are no longer visible. You'll need the zoomed in image to do some simple drawings, but you'll have to go back and look at the original image as you will need to know the sunspot group numbers. In the instructions, you'll see again the website that you need and a couple of different sets of dates that have good sunspot activity. The sunspots I showed you on the previous image are a good set too. When you open up the website initially, you'll see the sunspots for today. But if there aren't any good spots shown, you'll need to pick a different set of dates. You may use the dates that I gave you, or you may select your own, as long as there are sufficiently many sunspots to illustrate the point of the lab. You will be drawing sunspots for 6 days in a row to determine in which direction and how far they move over time. The series of 6 circles on page 2 is where you will draw your spots. Each circle represents the Sun. If I were to draw the set from 1101 that I showed you earlier, this is what I'd have to do. First, write the date. Notice that there are some areas of lighter shadow, called the umbra, and areas of darker shadow, called the umbra. I've also marked each set with their 4-digit sunspot number. Then, do the same for the next 5 days in order. You should see that the sunspots move over time. Show proportionally how each group moves, being as precise as you can. There are then 2 questions at the bottom. The second one asks you for rotation direction. How are the spots moving? Top to bottom, right to left, whatever. The first question, though, requires a bit of calculation. Though there isn't an equation for this, there's a tiny bit of math involved here. To answer question 1, you have to compare your day 1 with your day 6 image. Pick a spot group that is present in both and determine how far it moved in the 6 days you viewed it. As an example, say I had a group here in image 1 that moved to here in image 6. If it spanned the whole front of the Sun in 6 days, it would take another 6 days to go across the back, for a total of a 12-day period. Remember that a full rotation would mean the spun went across the whole front and the whole back of the Sun. Now, 12 days isn't the correct answer, but that's the process. Figure out how far your spot group went in 6 days. Determine how long it would take for it to traverse the rest of the front side, then take into account the back side of the Sun as well. Make sure to explain how you got your number, or you will not get points for this question. You cannot just look up the number in the book. The number must come from your drawings and data. Good luck with your lab and any midterm exams you may have this week.